Good morning.
Good morning.
Welcome to science class. Hopefully I can get this all done in our Bible class time period. Having finished up our study on death, Hades, heaven, and hell, need to have some suggestions on what to begin studying next. But just for today, I've been working on a sermon, and it wasn't coming together too well as a sermon, so I decided to make it into the Bible class for this morning. I think it's more suited for that. So we're going to talk about faith and science, particularly in the area of biogenesis. Notice it's faith and science. A lot of people want to make it faith versus science. But I think that when you see what I've got in the lesson, you'll understand why it's faith and science. Because when it comes down to the end, you see that in many instances, science is in juxtaposition or in conflict with science. So what we want to do is show how that science actually proves some of the things that the Bible teaches. So to begin our lesson, Genesis chapter 1, verses 1 through 3, in the beginning God created the heavens and the earth. The earth was without form and void, and darkness was over the face of the deep. And the Spirit of God was hovering, or King James says brooding. And it's kind of like moving over the face of the waters. It's like the potter's hands moving over the lump of clay as it's spinning on the wheel. Hovering over the face of the waters, and God said, "Let there be light," and there was light. Now, we live in a time that has benefited immensely from science and technology. I don't think any of us can disagree with that statement. Scientists are responsible for great innovations in the field of medicine and communication. For the last few hundred years, it's been great. That's just to mention two areas, medicine and communication. The reason scientists can do so much good is because they're working in an environment that lends itself to reproducible results. There are things that occur. You do X and Y, results from it, and it happens all the time. That's because we live in an orderly universe, or a cosmos, rather than a chaos. For example, scientists can send a rocket to the moon and have it return safely to the Earth because laws of gravity and planetary movement are constant and observable. Scientists have difficulty putting an astronaut on the face of the moon and returning that astronaut to the Earth if gravity was constantly changing, and if the planets and the moon were constantly changing speed in orbit and directions in orbit and all of that. You'd have to agree. If you remember, if you watched the movie Apollo 13, remember they're getting down. They've done all this scientific stuff to save the astronauts' lives, and they're getting about to the point where they're coming back to Earth, and they're coming in too fast. They're going to skip off the atmosphere and out into space. Well, why? What's the matter? If you remember what the problem was, they were supposed to bring so many pounds of moon rocks back with them, and they didn't land on the moon, so they didn't have that number of moon rocks, so they had to get stuff off of the lunar excursion module, the LEM, and bring into the capsule so that they could get close enough so that they could come down. They weren't sure that they did it enough in time to get them there. But that's how they figured things out, because there were basically scientific laws that said you do this and this will happen. But that all proceeds from what's called the scientific method. And this is just a chart I pulled off the internet, scientific method. Students use this, starting about, 5th, 6th grade? I wish I'd known this when I was like a sophomore in high school. I wouldn't have gotten thrown out of biology class. Okay, I'm sorry, Mr. Feldmeyer. I didn't understand that you didn't have to have something unique. You could do a different person's scientific investigation just to prove their point. Either it worked or it didn't work. Okay, so anyway, that's a hard story. That's a lesson learned from the past. But that's what scientists use. That's just a pattern. You have a question about something, you form a hypothesis, you do the experiment, you analyze it, you draw your conclusion, and then after you draw your conclusion, you go back. That would give you more questions, and if it doesn't give you more questions, what do? You analyze it, you do it again. You just go through it again, and somebody else does it again. Because it's got to be what? Reproducible. Reproducible. Now, science is a study of natural phenomena. Catch that word. Natural, but also phenomena. Phenomena means something that you see and it's there and you can experience, but you may not understand it. But it's something that is there. And it's natural, it's a study of natural phenomena by empirical observation. 5 senses. 5 senses. Okay. And the development of predictive models based on those observations. So it's got to be observable. Philosophy is a study of ideas by thinking about them and engaging in rational dialectic. What's dialectic? Well, but Marxism believes in dialectical materialism, okay? And what they say is, well, for example, the universe is always, well, I want to go away from that. In the area of politics, and it's something that we're going through in our nation today, is that there's always a class of people who are being oppressed, and there are a class of people who are the oppressors. And after a while, the oppressed rise up and destroy the oppressors, and then that goes along until another class of oppressors arise, and then the oppressed rise up. That's the back and forth movement, cycles in the history, so to speak, the dialectic. But when we're talking about a rational dialectic, that means a reasonable back and forth, which is, well, that's debate, isn't it? You got to talk about things, and that's what philosophy does, because you can't put your finger on it. You cannot empirically decide on a philosophical question. So it comes to debate, and in that debate you can form arguments, and you know there's a lot of different arguments, theological argument, did I say theological? Cosmological, there are tautologies, they're just all kinds of things that are developed there, and say, here's a formulary for determining if something is true or not, okay? And you argue on the basis of those things. Now, in the realm of philosophy is metaphysics. It's a traditional subfield of philosophy. It's concerned with how we ought to understand fundamental concepts such as time, space, existence, things, thoughts, substance, etc. Metaphysics go beyond empirical observation, okay? I've got this rock in front of me. I know it's a rock. I can feel it's a rock. I can see it's a rock. I hold it up. I hear it's a rock. All those things. But how did that rock get here is a question that empirical evidence may not give me. How did it come into existence? That's a metaphysical problem, not a physical problem. Understand? Understand that? Okay. So moving on, scientific laws are viewed as reflecting actual regularities in nature, and that's from a person by the name of Hall. I'm I assume it was a man, in Philosophy of Biological Science, page 3. Okay? That's not my textbook. You know, that's a scientific textbook. So to the extent known, scientific laws have no exceptions in this universe. Now, granted, scientists are trying to go outside and are still exploring in this universe, looking to see if there are exceptions. And there's even the metaphysical concept of multiverses. That, yeah, we've got a universe here, but there might be another universe over here and another universe over here, and things might be different in those universes because they may have evolved in different ways. Understand what I'm saying? And that's the multiverse concept. But this universe, there seems to be no exceptions. And if there does, then, you know, it's what we stated before. You know, I have my opinion will change when the facts change. And that's why we're always looking at, well, the facts. Give us the facts. Right. So, any observed discrepancies in the testing method or after the confirmation of the law are used to modify the hypothesis. So you go back, you've done the scientific method, and you go back, somebody else tests it and say, whoa, wait a minute, something's wrong here. And that's one of the things, and when we look at biogenesis, you know, you can cut off some things, you can cut off flies getting to raw meat, but that doesn't mean that you can cut off microbes from getting to it and still causing a rotting process. Maybe even forget I said that. But, okay, there are things that might change. You know, well, we'll change the amount of oxygen used in this experiment. That might change, you know, that might modify. There are things but if there's something wrong with it, the law would no longer be considered the law of science. Okay? It would be thrown out as a law. So the key word is observed. To the naturalistic scientist, only data that is observable or measurable is real. To the naturalistic scientist.
Well, that would be why those particular people have a problem understanding the concept of heaven, because you can't see.
Can't see it, God is the same way. You can't see him, can't hear him, can't smell him, can't taste him, feel it, all of that, okay? God is not testable in a laboratory, right? Because that is a metaphysical question. And science is only dealing with the physical. So unless phenomena can be repeated in a laboratory, it did not occur. So there is a scientific law, a regularity which applies to all members of a broad class of phenomena. That's why this happens. Where does the sun rise? And that's what we call it, the sun rising. We know the sun doesn't rise, the earth turns. Where does the sun rise? In the east. Where does it set? In the west. That's a broad category of phenomena that we see. That's a scientific law. If it changes, what happens? Something bad happened overnight. You know, something bad. Now, the law of biogenesis. Considering that, an abiogenesis would be spontaneous generation, which in essence, we're talking about the opposite of biogenesis, and it's the same law, but typically it's called biogenesis. All right? Life comes only from preceding life and perpetuates itself by reproducing only its own kind or type. This is something that has been, okay, life comes only from pre-existing life. Experiments run over 2 centuries. All get the same result. All right, Louis Pasteur, Reddy Spallanzani, All of them have done this, and the spontaneous origin of life is impossible, and that's what abiogenesis is, okay? Not life genesis. In other words, life just started from dead materials, okay? Still doesn't tell you where the dead materials came from, but this is what the law of biogenesis it is setting up, where it comes from, basically. So, up to the time of Louis Pasteur, men overwhelmingly believed that life was spontaneously generated. Rotting meat produced maggots and flies. That's what they thought. You leave meat out, and that's where maggots and flies come from. Rotting meat. But after Pasteur, what he discovered was, well, it's because flies lie on there and they put their eggs in there, and the eggs turn, they hatch into maggots, and then the maggots become flies. So life came from life, not from dead meat. So that changed the world. The people used to believe, and scientists taught, trash is where mice came from. You leave trash laying around in your house, that's where mice come from. Probably cockroaches too, whatever. And the technical word for such belief is biogenesis. Okay? Life coming from non-life, but something that was dead, producing life. Kind of like Frankenstein's monster. You got two things in the science movies, right? You got Frankenstein's monster. You take dead body parts, put them together, and then induce an electrical charge, and what happens? Life! He's alive! It's... you got a second one that's really becoming prominent right now. Because where do vampires come from? Or what do vampires change into and out of? Bats. And where did the coronavirus come from?
Supposedly from bats. Now, no, it's not the case.
Oh, no, it's from bats. But in a laboratory setting and engineered.
Actually, they're immune to the bats are what I just heard.
But not to this level.
Right.
It could, just like bird flu and swine flu, unless they go back and they find that there were people engineering those back then. But this, you see how science fiction was so far ahead of itself? All right, so Pasteur is able to accomplish two great things. Number one, he's able to show that to keep flies off the rotting meat, no maggots or larvae develop, and hence no flies. Also the same with the trash, no mice, to keep the mice out of there, right? If you heat milk to a certain temperature for a certain period of time, germs are killed, which normally speed up the spoilage of the product. In other words, milk will still spoil, but it takes longer for the milk to spoil if you pasteurize it. Okay, the process is named after him. And the government, on the advice of scientists, demands that most, not all, milk and juices sold in stores be pasteurized for that purpose. Okay? So, you understand about the scientific method, how something basically becomes a scientific law and such. Okay? Consider some quotes about scientists regarding the law of biogenesis, and this is from scientists. Historically, the point of view that life comes only from life has been so well established through the facts revealed by experiment that it is called the law of biogenesis. This is from the textbook, Biology, A Search for Order and Complexity. It's written in 1974. That's on page 74. And this is what they're saying, that it's so well established that it's called a law. A century of sensational discoveries in the biological science has taught us that life arises only from life, that the nucleus governs the cell through the molecular mechanisms of deoxyribonucleic acid, and that the amount of DNA and its structure determine not only, catch this, the nature of the species, the classification, but also the characteristics of the individuals. The blueprint is in there through the DNA. Life arises from life because of the DNA and the RNA and the amino acids, the proteins, and all of those things working together, but the blueprint is there. And it determines the nature of the species and the characteristics of the individuals in each species. Okay? Going a step farther, or further, the law of biogenesis is called a super law. Super law? That must be something very special. Well, it is. This means that other laws are derived directly from this law. So you've got this law, the law of biogenesis. Because of this law of biogenesis, other laws, okay. For instance, in the Ten Commandments, thou shalt not shed innocent blood, which we call murder, right? That is one of the big 10. That's a super law. But underneath that, you have some other laws, right? How about you shall not hate your brother without a cause? Other things underneath that category that would stop you from getting to that category of shedding innocent blood. Understand what I'm saying there? All right. So that's what the law, this super law is. You have the law of biogenesis, but under that you have other laws associated with that because of that. And, you know, one of the first things that students study, and I think I come along at probably 7th grade science class, whatever, Mendel's studies on peas, right? Gregor Mendel studied peas and got out of, here's how peas, you know, they grow and this is how they change and whatever, the reproduction of peas. And, well, that's all because of this law of biogenesis. Kind produces after kind. But what you have is that in this kind, you have differences that appear in these, just like human beings. Some of us have blue eyes, some of you have brown eyes, right? Blonde hair, brown hair, tall, short, big and round, skinny and small. Yeah. All those kind of things are set up in the genetic system to a large degree. Same thing with peas, and that's what Mendel's studies show. So if the law of biogenesis is not correct, then Mendel's law of genetics cannot be laws. It just wouldn't work, right? If kind doesn't produce after kind. He'd plant peas and he'd get green beans. Did somewhere along the line green beans turn into peas? Maybe, maybe not. Nobody knows. That's a metaphysical question, isn't it? Okay? So, the main point of the lesson is this. If someone wants to accept evolution and reject creation as the way the universe began, then that person must deny the law of biogenesis. Does that make sense? I don't believe in creation because I can't put it in a laboratory. I don't see it happen. Well, let's go with some things. Evolutionists holding to the theory of macroevolution. Why do I say macroevolution? Because it just talked about microevolution and showed that it works. That's what Mendel was teaching, wasn't it? Yeah, that the bees could be different, but also human beings. A human being creates or reproduces a human being, but because of the genes and the differences in the genes, might be blue-eyed, might be brown-eyed. And there you have it. That's microevolution. But macroevolution teaches that, has to teach that, matter is eternal. It has to teach that. Why? It had to come from somewhere, or it had to always exist. Now, if it didn't always exist, it had a beginning point. Well, what's that beginning point? Who knows? Well, the Marxists, again, would say, oh, it's dialectical materialism. The universe explodes and expands, and then comes back in, and then just starts over again. And it's done that it's eternally done that. Well, where did it begin doing that?
It's magic.
But that's how they try to solve that problem. Then we do know by the laws of thermodynamics that this universe is expanding, but it's slowing down. And at some point it would cease to expand and start to contract, if it would last that long. So, at some point in time, for no apparent reason, this is what the evolutionists would have to teach, matter organized itself into galaxies and stars and solar systems and planets, right? At some point in time, and for no apparent reason, in this universe, in one galaxy, in one solar system, on one planet, matter organized itself into life, which would be biogenesis, which is spontaneous generation, which according to what? The law of biogenesis is impossible. But that's what the evolutionists would have to teach
Call that
and
Big
have to
Bang,
hold to.
Big Bang theory, don't they?
But that's the same concept. The matter was there, and somehow that matter exploded into life or whatever. It's like laying a matchstick out here, and how long is it going to sit there until it explodes without any outside influence? How long will it lay there until, boom, it lights on fire? It's going to sit there forever, right? There's got to be an outside force. Right. According to the scientific method, for macroevolution to be true, that's this matter was eternal, and it for no apparent reason organized itself, and then for no apparent reason produced life, right? A scientist would have to observe eternally inert matter somewhere organizing itself into a known universe and producing dynamic life. Do you suppose that maybe that's the reason for the Hubble telescope? The scientists are looking for that. We still haven't found it, have they? Okay.
If it did happen, it would continue to happen. Why did it stop? You know, that's only half of
Exactly.
the theory there.
Right, but if it did, would it be in this universe?
Yeah, because it created this universe. Now that over there would be another.
But you would think it would, if it was going to, it would create a different universe, and that's where a multiverse would come into play. But again, it still does not help the evolutionists calling this a law, and then going back to that point and saying, well, this law doesn't count here. at the beginning of this universe, wherever it started. Okay? So scientists have to observe eternally inert matter organizing itself into a known universe and producing dynamic life. And I think that might be a double entendre, or not in a negative sense, but dynamic would be active, but a living thing. Okay. Secondly, eternally inert matter organizing itself into a universe other than the known universe. And that's what, hey, we're going to take these chemicals and this material, and we're going to take it to the laboratory, and we're going to do some stuff with it. We're going to put electrical charges through it, and we're going to try to produce life through that. And like the old guy said, get your own dirt. Make your own dirt. Create your own dirt. They're not doing the experiment the right way. Go somewhere. Make your own dirt. Don't use dirt that's already here. It's got to be totally different, okay? But then producing life apart from life known in this universe. See, all that would need to be observed. Observed. And third, eternally inert matter organizing itself into a universe and producing life must be repeatable in a laboratory under controlled experimentation. And I think that's an impossibility. How could you create a universe in a universe? Even though Men in Black, they did have a galaxy in a little deal that the cat wore on its collar. A galaxy, not a universe, a galaxy, right? If I can get you to believe that there are multiverses, and I can get you to believe that galaxies can exist that would exist here, I could probably get you to believe that inert matter organized itself for no apparent reason, and for no apparent reason, came to life. Think so? Now, the anti-creationist finds him, and that's why I say instead of calling them evolutionists, because again, you have to split between macro and micro evolution, the anti-creationist finds himself on the horns of a dilemma. And that's a philosophical position, right? It's a position you get to in debate. To hold to macroevolution, he must state that something which is not empirically proven, poiesis, which is life coming from non-life, he has to state that that happened, or he must say that something which has been empirically proven, the law of biogenesis, is not true. Catch that? He has to say, well, life does come from non-life, where he has to say, the law of biogenesis, that life only comes from life, isn't true in all circumstances. Okay? Secondly, to accept macroevolution is to deny science, which the law of biogenesis. While to accept the law of biogenesis is to accept what? Creation. What the Bible says in Genesis chapter 1. So what scientific laws must the creationist give up in this debate? None. Creationist doesn't have to give up any scientific law in this debate. A law, something that is reproducible, basically, something that has been shown over and over. The law of biogenesis, we don't have to give that up, do we? Well, consider the law, the Bible, and the law of biogenesis. Look at Genesis chapter 1, verses 11 and 12. And God said, let the earth sprout vegetation, plants yielding seed, and fruit trees bearing fruit, in which is their seed, each according to its kind, on the earth. And it was so. The earth brought forth vegetation, plants yielding seed according to their own kinds, and trees bearing fruit, in which is their seed, each according to its kind. And God saw that it was good. Has that ever changed? Now you can graft like what, an apple limb to a peach tree, or maybe vice versa, whatever, and you can get a different fruit off of that tree because the sap will come through it, but it's because of that limb, and the fruit of that tree is still going to produce whatever that fruit is if you plant it, and it's going to grow. If you put a peach tree limb, graft it to an apple tree, the fruit of that's still going to produce a peach tree, right? That doesn't change. Genesis chapter 1, verse 24 and 25. And God said, let the earth bring forth living creatures according to their kinds, livestock and creeping things and beasts of the earth according to their kinds. And it was so. And God made the beasts of the earth according to their kinds, and livestock according to their kinds, and everything that creeps on the ground according to its kind. And God saw that it was good. Okay. Well, what happens if you take and you cross a mule and a horse? I'm sorry, a donkey and a horse. A donkey and a horse, what do you get? A mule. And what happens if you cross a mule and a mule? What do you get? I don't think you get anything. Because that's a mutation. And if you do get anything, it's going to revert back to be either a horse or a donkey. And you can look that up. I think that's correct. I don't know but mules, that's how you get a mule. You breed a horse and a donkey.
I believe they're sterile.
They may be sterile, but if there is a chance that they do reproduce, like a mule with the horse or a mule with a donkey, it comes back to whatever that other animal, it reverts back. But because it's a mutation, it's sterile, or it does not produce kind after kind. And that's why a mule, mule's treated differently in the Bible. Read through it. Okay, and then Genesis chapter 2 and verse 7. Then the Lord God formed the man of dust from the ground, and breathed into his nostrils the breath of life, and man became a living creature. God did not form man or create man, bring forth man from a monkey or from a bat. Okay? Created man. Formed man from the dust of the earth and breathed into his nostrils the breath of life. And man became a living creature. Something very special in God's creation. So that's what I've got there, and that's the point I want to show. Lots of times, what we want to do, and I'll throw this out there in this way, as Christians, is deny science and berate science. And what we really need to do is show where science and the Bible are compatible. And show. And when you're talking about creation itself, the fact of creation is a metaphysical problem. A scientist is not going to find an answer for that. The origins of the universe somewhere. a universe being confined some eternally inert matter that forms itself, organizes itself, and from that produces life without any outside interference. No, we believe that there's an outside interference that leads to God, but we also believe some other things also along with that. We believe that there is a God because we see the evidence of God. We see the order in the universe that you can have laws like the law of biogenesis. Because there is order. It's a cosmos. And because there's order, there had to be somebody who put it into order. That's my lesson for today.
I think you can commit to the fact that science supports the Bible, but the men practicing science, men, again, it's not the science, it's the man that causes the conflict.
Mm-hmm. Because at a point in time where they want to take science and move their science into the metaphysical realm and say, this is what science teaches, that there is no God, well, that's moving into a different realm. And that's where they have overstepped.
The original chart you showed it ends in conclusion. They start with their conclusion and try to prove it.
And go back.
They've already decided what they're going to believe.
Yes.
Now they got to convince you.
Because to many of them, it becomes a religion to them. And the main reason is because when you're dealing with God, you have morals involved. And as we just studied in our last series of lessons, a judgment that's going to come. And a lot of people don't like to hear that. Anyway, that's our lesson. Thank you for your